Welcome to my YouTube channel. In this video lecture, I'm going to answer questions from Keith Williams' Weight and Balance book, Chapter 1, Basic Questions. This chapter consists of 100 some 100 questions regarding basics of weight and balance, meaning namely the formulae, the definitions, the conceptual questions, theoretical questions, simple math questions. So far I have done 80 questions. In this video lecture, I'm going to do the next 10 questions, questions 81 to 90. So let's start. Question 81. The zero fuel mass of aircraft is imposed to prevent excessive wing root bending stresses. DOM plus traffic load and operating mass plus the traffic load specified in the flight manual produced by aircraft manufacturer. Okay, so we always start with the basic empty mass. Now, when we add variable loads to basic empty mass, we get dry operating mass. Okay, variable load plus basic empty mass equals to dry operating mass. Next, dry operating mass plus takeoff fuel or fuel on board equals to operating mass. Okay, so takeoff fuel or fuel on board equals to operating mass. Dry operating mass plus payload will give you zero fuel mass. Will give you zero fuel mass. Operating mass plus payload will give you takeoff mass. Similarly, zero fuel mass plus takeoff fuel will give you takeoff mass. So payload here and takeoff fuel or fuel on board this side. Now, another way to find out takeoff mass is DOM plus useful load. DOM plus useful load equals to takeoff mass. Now, what is useful load? Useful load is nothing but takeoff fuel plus payload. Okay, that is useful load. So, zero fuel mass is nothing but dry operating mass plus payload. So, option alpha is a correction. Option bravo is the right one. Specified in the flight manual produced by aircraft manufacturer? No. Zero fuel mass will change from flight to flight. What is zero fuel mass? It is nothing but dry operating mass plus payload. What is payload? Passengers, passenger baggage, their cargo, etc. So this makes your zero fuel mass. Now payload will change flight to flight. In holiday seasons, festival seasons, will have more payload than we will have in some other season, off season, right? So more passengers, more baggage, more cargo. So zero fuel mass will also increase in that proportion. Less passengers, less baggage, less cargo, so zero fuel mass will also decrease by that proportion. Therefore, zero fuel mass will change from flight to flight. It will not remain fixed and therefore it cannot be written in a manual. Whereas maximum zero fuel mass, the maximum limit can be written, but otherwise the zero fuel mass with which we fly every day will be changing every time we fly. So delta is wrong. Operating mass plus traffic load. So operating mass plus traffic load or payload equals to takeoff mass. So that is also wrong. Next, define useful load of aircraft. So what is useful load? Takeoff fuel plus payload or traffic load equals to useful load. The part of the traffic load which generates revenue for the operator? No. So traffic load, remember, traffic load equals to, although we use traffic load and payload interchangeably, there are some questions in which we will have to stick to the specific meanings of these two terms. So traffic load will be equal to payload plus non-revenue load. Now what is payload? Payload is nothing but passengers plus cargo plus baggage, right? And non-revenue load will remain as it is plus non-revenue load. Okay, so this is your Traffic load. So traffic load is payload plus non-revenue load. So the part of the traffic load which generates revenue for the operator is called payload. It's not useful load, it is called payload. Obviously, passengers will pay for their tickets, will pay for their baggage, cargo, right? So payload generates revenue, whereas non-revenue load, as the name suggests, doesn't generate any revenue. Option Bravo, traffic load plus reserve fuel load, no. Traffic load plus usable fuel, yes. Dry operating mass plus usable fuel. So dry operating mass plus usable fuel meaning takeoff fuel, the fuel in the fuel tanks when your aircraft is positioned for takeoff on the runway equals to operating mass. So that is wrong. So we are left with option Charlie. Now the fuel that we are talking about is the takeoff fuel, the fuel on board, okay, or in other terms, useful fuel, the fuel that we are going to use. Okay, so traffic load plus usable fuel. 83. Which of the following are included in the variable load? Now, what is variable load? Basic empty mass plus variable load gives you dry operating mass. This variable load is includes flight crew, flight crew baggage, okay, uh, food, materials, water, etc. Okay, so all other removable equipments. So traffic load plus usable fuel. So traffic load plus usable fuel is nothing but useful load. Okay, so that is wrong. That is not variable load, that is usable, useful load. Traffic load plus unusable fuel, there is no such definition. Removable equipment, toilet chemicals, unusable fuel, removable equipment, toilet chemicals, beverages, and crew. So option delta is the right one. Unusable fuel is a part of basic empty mass. It's not a part of variable load, it's a part of basic empty mass. So removable equipment like food, water, all that, toilets, lavatory, and beverages, crew. So which of the following best defines maximum zero fuel mass? Now here we are talking about maximum zero fuel mass. The actual mass when aircraft is loaded ready for flight but has no usable fuel on board, greater of maximum takeoff mass or performance limited takeoff mass minus trip fuel. Wrong. We always choose a lesser value, not the greater value. Okay. If we have to consider, if we have to make a choice between maximum takeoff mass and performance limited takeoff mass, we go ahead with the lesser value. Okay, the maximum operating mass plus takeoff fuel. This will give you takeoff mass, not zero fuel mass. Maximum permissible mass of aircraft when it is loaded for flight but has no usable fuel on board. Okay, so the correct answer is maximum zero fuel mass. Maximum zero fuel means no usable fuel. The aircraft will still have unusable fuel, but but here maximum zero fuel mass means no usable fuel, no trip fuel, no startup taxi fuel, no diversion fuel, no alternate fuel, no extra fuel, nothing like that. So actual mass when aircraft is loaded. So here they are talking about actual mass, and here they are talking about maximum permissible mass. So the correct answer is option delta. Actual mass. You will select a statement number A when they're talking about just the zero fuel mass, which will change from flight to flight because payload will change from flight to flight. But maximum zero fuel mass is the maximum limit, which will remain constant whether you fly in a holiday season, festival season, or an off season, whatever. So it is the maximum mass of aircraft when it is fully loaded for flight but has no usable fuel in the tanks. The longitudinal distance between center of gravity and datum is, so this question is a repeated one. So let's say this is your aircraft. Now the manufacturer of this aircraft will determine the forward limit of center of gravity and the aft limit of the center of gravity. Forward limit and the aft limit. There will be an imaginary plane called datum from where center of gravity calculations will be made. Okay, So the center of gravity calculation will be made from this datum. Now this datum can be outside aircraft like here, or it can be in your inside aircraft. There's somewhere here, here, here. But it must be only on the longitudinal axis of aircraft, not the lateral axis, not the vertical axis. Okay, so reference datum is the fixed. Center of gravity can move, but it can move within this range only. So this distance, the distance between them is called, the moment arm or balance arm. That's balance arm, delta. Okay, next. 86. Which of the following is correct? Moment equals to mass into arm. Moment mass divided by arm. Mass equals to weight into gravity. Arm equals to gravity into mass. So Charlie is wrong. Weight of an object equals to its mass into gravity, not the other way around. The Bravo and delta are also wrong. The correct answer is moment equals to mass of an object multiplied by the balance arm, this arm. Okay, that it gives us moment. Remember this. You will have to make these calculations when you start flying. Okay. Index is what? Index is arm divided by a constant, a moment divided by a constant, a moment divided by a variable, or an arm multiplied by a moment. So correct answer is Bravo. So an index is a non-dimensional quantity. So it doesn't have any dimensions. No centimeter, meter, kilometer, kilogram, nothing like that. Now over here we saw this formula. Moment equals to mass into arm, right? Now, when you do these calculations, normally we get moment values, the values of moments in large values. Okay, we get large values of this moment. For example, 24, 5, 0, 0, 7, 0, 5, something like that. So, in order to simplify our calculations, we always divide these large numbers by a fixed constant. For example, in this case, we can choose to divide it by 10,000. So, when we do that, we will get 2450. Okay, so we will divide all the numbers in such a numerical by 10,000, not just the moment but other things also. Okay, so 10,000 to simplify our calculations, right? So I always do that even in my payload questions. If you have seen my payload questions lectures, payload like takeoff masses will be given in terms of 85,560, let's say. Okay, landing mass 75,890. Zero fuel mass 61,246. Whatever. So what I usually do is I divide all these values by 1000. Okay, to simplify the calculations to save time especially. So 85,560 divided by 1000, a constant, will give me 85.56. This will give me 75.89. This will give me 61.246. Okay, so this makes my calculations easier. Okay, so similarly here, and that this is called index, the number which you use to divide. Okay, a moment divided by a constant. It's a constant number. It stays constant, the same throughout that numerical sum. What is the minimum number of seats that aircraft must have in order to use standard baggage masses? So the number of seats required is 20. Okay, so minimum 20 seats must be available in your aircraft if you want to apply standard baggage rules. And if this such an aircraft is flying on domestic flights, domestic routes in Europe, the standard baggage per person is equal to 11 kg. Anywhere within the Europe, in the European region, is equal to 13 kg standard baggage mass per person. And intercontinental flights, that means you are flying outside Europe to Europe. So the standard baggage mass will be equal to 15 kg. Remember this. Next. Which of the following best defines zero fuel mass? Just the zero fuel mass of aircraft. Actual mass, okay, actual mass, the current available mass right now, when aircraft is loaded ready for flight but has no usable fuel on board, lower of maximum takeoff mass and performance takeoff mass minus fifth fuel, uh, operations mass plus takeoff fuel, maximum permissible mass when it is fully loaded for flight but has no usable fuel on board. So now this question is similar to the one we did a few minutes ago. Over there they gave that question was about maximum zero fuel mass. Over here it's just the zero fuel mass. So the correct answer is option alpha. Current mass, actual mass right now. Now, lower of maximum takeoff mass or performance limited takeoff mass will give us a regulated takeoff mass. And when you subtract trip fuel from that regulated takeoff mass, you get regulated landing mass. Okay, so Bravo is wrong. Operating mass plus takeoff fuel. Okay, there is no such thing as operating mass plus takeoff fuel because operating mass is already inclusive of takeoff fuel. Why? Dry operating mass plus takeoff fuel or fuel on board equals to operating mass. So you cannot add takeoff fuel again. Delta is wrong because here they are talking about zero fuel mass, not the maximum zero fuel mass. Had they, uh, should they talk about maximum zero fuel mass, you would select maximum permissible mass, option delta. Next. What is the maximum mass of fuel that can be mass? They are talking about mass means kilogram that can be loaded onto an aircraft if tank capacity. Volume of this fuel tank is 3,750 US gallons and specific gravity or density is equal to 0.792. So specific gravity equals to mass in terms of kilogram divided by volume in terms of liters. Okay, so our first job will be to convert this volume US gallons into corresponding liters. You are going to, so how many US gallons? 3750. Now 3750 US gallon. So press the convert unit button till you get liters. Okay, so how many liters? 14195. 14. So write it here. So mass will be equal to 14195. So mass will be cross multiply 0.792 14195, that is equal to 11,242 kilogram. 11,242 kilogram. Simple. So this concludes the lecture. I hope you have understood all the 10 questions I answered in this video lecture. Hope you learned something new today. If you have liked this video lecture, don't hesitate to hit the like button, subscribe to this channel if you haven't yet, and share this video lecture with your friends. Thank you for your time. In my next video lecture, I will be doing the next remaining sums. See you then.